Okay, so we're going to look at transformations that involves vertical shifts and phase shifts of sinusoidal functions today. So first, we have a vertical shift. So that is if we have a number that's just added on the outside of our function. So in this case, we have the original sine theta functions already graphed for us, and I'm asked to graph sine of theta plus 1. So in this case, I look at my 5 basic points at 0, 90, 180, 270, and 360, and I'm just moving them all up by 1. So I'm going to do that in blue. So in blue, I'm moving up my 0 to 1, so everything's just moving up 2 squares because every square is half a unit. So everything's just getting moved up by 1, and then I just draw my curve between all of those points and try to get it as smooth as possible. Okay, so that is if I'm moving it up by 1, and then next is I'm asked to do cos of theta and cos of theta minus 1. Cos of theta is already graphed for us, so now I'm just drawing cos of theta minus 1. So I start with my 5 main points, and then I take each one and I move it down by 1. So I'm moving each one of those points down 2 squares, and then I do my best to draw a curve connecting those 5 points. So if there is a positive number on the end of our function, then we say it's a vertical shift up. You can also call it a vertical translation up. And if our number is negative, then there's a vertical shift down. Next, we're going to look at phase shift. So here, I'm going to be doing horizontal shifts. Although in sinusoidal functions, we actually call these phase shifts. So even though I'm going to be moving the graph, I'm going to do some horizontal translations to the left and right. We're calling that phase shift for sinusoidal functions. So here I'm asked to graph sine of theta minus 90 degrees. And you'll notice that this is inside of brackets always, right? So our phase shift, one of the ways that we can tell if it's going to be moving left or right is whether or not it's inside of the brackets or outside of the brackets in our function. So here we have minus 90 degrees, and just like in Unit 1 when we were doing horizontal translations, now we're going to be moving this 90 degrees to the right. So we're moving this 90 degrees to the right. Every year when I teach this, students are always thinking, what, it's a negative sign, I should be moving it to the left. But inside of our brackets, it's like it's kind of lying to us. So always inside of the brackets, it's going to be the opposite of what you think it is, and then on outside of the brackets, it's exactly what you think it is. So here we're starting with our 5 main points, and we're just going to move all of them 90 degrees to the right. So in this case, every square is 30 degrees because 3 squares is 90 degrees. So that means I'm going to take each one of these points and move them 3 squares to the right. So this one got moved 3 squares to the right. This one's getting moved 3 squares to the right. And then all of them are just getting moved 3 squares to the right. So when I end up drawing my curve between my new points, I end up getting this curve that was shifted over, right? And if I wanted to continue it, you can just kind of continue to draw that pattern as well. So I could even just continue drawing it, and there we go. All right, next I'm asked to do cos of theta plus 45 degrees. So the last one was moving to the right because there was a minus sign. This one's moving 45 degrees to the left. So I start with my 5 basic points, and I'm going to move them each 1.5 squares to the left. And that's because every square is 30 degrees. 3 squares is 90. That means half of 90 is 45. So I'm moving everything over 1.5 to the left. So this first one gets moved over here. Next one's getting moved here. That one gets moved there. And now once I have all my points, I just do my best to draw a curve between those points. And if you find that you're having difficulty doing this without more than one color, something else you can do is you can draw like different shapes. So you could do like an X instead of just different colors. And that way you know which points you're trying to draw your curve between. There we go. So if the phase shift was positive, if there's a positive in our brackets, there is a vertical translation to the left. You can call it vertical. I meant horizontal. There is a horizontal translation to the left, or you can call it a phase shift. And similarly, if it is negative in the brackets, then there's a phase shift right. All right, so here we have a chart that I would like you to copy and complete on your own just to practice what we've learned so far. We'll do the first one together. So here I notice that there is a number in front of my function. And I remember that that number represents the amplitude. In this case, there's no number in brackets, so there is a phase shift of 0. And I notice that on the end there is a number, so that's my vertical shift of 0.5 up. So I could say of positive 0.5, or I can just draw a little arrow to signify up, or I can actually say 0.5 up.